Okay, we are live. Hello. I said I'd be back. Dinner took longer than expected. But I am in fact here. Cool. So I realized something with this kernel that is going to be a problem. Yeah, the thing that's going to be a problem with this is, isn't this going to output like specific shape kernel? Let's go look. So we just do obs. Obs, not real. Exit. Hello, off market. Welcome. Okay. We want this, and we want debug. Yo, what the hell? Oh, I did the wrong one. Hang on. Alright, so we just do tiny model obs realize exit. Rewrote 4 graphs. So this is element wise and a reduction, I believe. Thank you, oxidative. It's a nice space. Yeah, so let's go look at this kernel. Now this is the thing I'm not sure about, right? Because this is going to give us... This has all the shapes in here, right? You see... I realize... Schedule uops. Used. This is not what we want. View program. I think this is it. Hey, Spencer. I am busy breaking my head. How's it going? Working on project AI-driven space situational collision risk detection. Cool. Yeah, what the heck is this? Oh, did it just unroll? Ugh. Yeah, this kind of just unrolled everything. Right? So I guess we look at... Does TinyGrad have the ability to generate us kernels that are not shape dependent? Or like are not hard coding the shape? Beam. Number of beams in kernel beam search. Float 16. So do I have to do this without beam, or what do I do? What happens if I do... What happens if I do it this way? Do I get something different? Well, now you get 3 kernels. Reduction, but these are still, yeah, so here you actually, this is not full unrolled anymore, right? Or is it, was I looking at this one? No, it's still like this. And this gives us... Yeah. Okay, so, I mean, you see the issue here, right? It is generating good kernels, but it's generating, like, specialized to a specific shape. So that is a problem, right? Because we'd basically... We would have to include tinygrad in... It would have to go into Puffer, I think. And then it would have to, like, the installer, whatever, would have to actually benchmark, or would have to run tinygrad to generate your kernels. Hmm. Yeah, that's an issue. Like, instead of using unroll or something, it just manually unrolled it. So it wrote, like, this very non-readable kernel. And also, like, there's no way I can adjust this and just use it. Index, reduce, add, mul, add, square. Yeah, so this is your, like, little computation graph for an RMS norm. So this thing is cool, right? But then it generates a kernel that I don't see how I can use, which is an issue. Doc describing speed, compile speed, fast graph rewrite. Yeah, okay. Tiny jet. Best execution speed of any framework because it usually bypasses the GPU driver, rebuilds the command queue. So then where is the overhead then? Why is this not just faster? Do you still want to use tinygrad? I'm looking, man. That's what I'm assessing right now. Often even faster than CUDA graph. Model speed. Scheduler determines how operations are grouped into kernels and which tensors are written to memory. Kernel speed determines how fast the operation is done. Yeah. Beam changes. Ops that control the parameters of speed operation. Applied to kernel. Hello, welcome. So, I mean, this is the first legitimate question. Where's this? I had a doc somewhere, didn't I? Where did I write this? Here we go. Kernel gen not and fixed to a speed. Oh, that's obvious. Kernels. And like, yes, I'm obviously aware that it's going to be faster if you tune everything. But like, basically I'm thinking if you tune the block size for smaller nets, for instance, and then you still ship it, like... Main bottleneck in most kernels is accessing memory. Terabyte of RAM bandwidth and flops. You use each loaded value 100 times. They're using it in production, so it should have a reason why they migrated. They are... Who is they? Like, there are a lot of good things here, but then there's some things missing, basically, is what I'm seeing so far. Okay, this is a reference. Well, because it's Potts' own thing, and it got good enough that they could have, like, yeah. Blinding white page, but... Let's see. Compiling kernel code. Launch dimensions, buffer sizes. Using... Four by four matrix element-wise addition might render this CUDA code. 1 plus Huh? Oh, I see. So I guess then, yeah, the question is, can we get this to generate generic kernels? Because otherwise, right, like, we would have to ship we'd either have to ship every possible op size, which isn't realistic, or yeah, that's pretty much it. Or we'd have to bundle tinygrad with it, which is not what I want. Yeah, PyTorch is easy. Like, TensorFlow is shit library, yes. Buffer. Adding the same tensor price. Alright, these. Okay, this is niche. We have this. This is quite nice. Okay. Yeah, we do this type of stuff. It's fine. Yeah, okay. Yeah. That's fine. So, where does this leave us? Because, like, it's outputting. I guess I didn't expect it to output a shape-specific kernel, right? Like a hard-coded kernel for the shape. Like, you can really only use that for inference if you have, like, one specific architecture. Let's check another thing. Yeah. Let's go check, because we had the other, now that we have a little bit more knowledge here. we can do like test tiny grad test torch. Okay, so for test tiny grad, we get context beam 2. Now we get faster than torch. Faster than torch eager at least, and torch compile is a pain in the ass. So I can do like this, right? And it'll take a while. And it'll just completely mess up. Just like, good job, torch. If I do max auto tune. Yeah, it's still worse. What about reduce overhead? Yeah, surprisingly, still worse, right? Can try getting rid of full graph. Yeah, but it's slower. So, torch compile kind of sucks. And actually, tinygrad is faster on this benchmark by a little bit. Let's do, whoops, 6. So, this is pretty consistent with what I've seen for a long time. Oh, but hang on, you know what I think we're doing wrong here? We're doing one thing wrong. This will potentially change it quite a bit. I totally forgot this. Hi. Torch dot was it? Torch dot backends dot CUDA allow. Does this not help? Interesting. Yeah, so interestingly enough, this does not help at all. Oh, hang on, this doesn't have a bias. List object. Has no attribute requires grad. Where is there an API? In here. Come on. In-out bias. What did I do wrong here? Oh, because this is the wrong thing. Cool. So now, of course, this has to retune the beams. Yeah, I had extra list. My bad. Yeah, it's probably a list. Yeah, there's the delay on X. All right, 19 mil. So that takes a little bite out of perf. It's very funny, but still just a little bit faster than torch on this. Let's make this as minimal as possible, because I think my goal is going to be to have like a few clean examples we can use for demos. So we have this, warm up, flops, torch, tiny grad. Cool. So relu, this. I don't need dot flatten of one either. Redundant. Now we have the equivalent in torch. It's funny that torch actually doesn't get any faster from this at all. So I do wonder what precision TinyGrad is going to use. The docks are lacking for sure. New to Python, 2 hours a day. What are you doing here? Oh, you have stumbled into the deep end here. I am a reinforcement learning researcher, and I stream all of my dev. So what I'm doing at the moment is I'm looking at TinyGrad's performance for small networks versus torches, and then if it beats torches versus my own custom GPU operations that I have. And we're going to see if this thing is any faster, and if there are any ideas that I can use generally in the rest of what I work on. Yes, welcome to the Matrix. That's a good way of putting it. There are tons of educational resources around here, though. I do make some content for more beginners. Does this thing have docs over, like... import global counters? So global counters will do this same op as I have, it'll do this for me, right? This flop count. Where do I get... If I wanted to do BF16 or TF32, like, where do I do this? Does this have BF16 anywhere? Not really. Do we have D-type? We have B float 16. Why is there no T float? Why is there no TF32 here? Oh, also, did that not even index correctly? No, it did index. Yeah, why is there no tensor float? Reading the code and examples is easier than the docs. I mean, that's kind of acceptable. Examples are good, but in this case, like, there is some level of API rep I would expect. Stuff like this is good. I'd like to have this for, like, everything. The example should at least be linked. Let me add that to my notes. Tab. So if I search this one for tfloat32, nope. Well, I used the wrong search bar. Hang on. Allow TF32. Oh, this is on by default. I see. mvars md. Why is mvars md better than the nvars? Am I stupid? Hang on, let me just make sure this isn't me being stupid. Because if it is on the docs, like, so bright, fair play. Environment variables. Okay, I'm dumb. This is literally directly served from the same page. Cool. This one is me being stupid. 100%. But, like, I wouldn't expect to look for it in nvars. To look. Wow. In vars, etc. Things are not where you would expect them to be. Is this, wait, is this on by default? Same speed, right? Apparently it is. Get rid of this. Needs a bias is true, which would be default. Linear relu. Fuel. Alright, so tinygrad wins a little bit on speed here. Now, mind you, the one thing that's a little annoying is, so Torch is supposed to have all this compile stuff. It's not actually faster a lot of the time, especially for these small models. But just look at this. If you don't compile tinygrad, I just want to show you this. So if you do not run tinygrad with compile, you take a 3x speed hit. See you, Tom. No idea what's going on. Fun to watch. Cool. Thanks for dropping by. I have guides on my X. Okay. So now that we have a decent number of people here for the evening, does anybody have any requests or things on this example before I move on? Like, do we all agree that I've done pretty much as is reasonable for a basic linear net to compare Torch and tinygrad? For this, like, this one example. We're going to do a couple more examples, of course. Looks like you're using their JIT. Yeah, I'm using their JIT, and I'm using their beam search as well. Is this supposed to be 2, or am I supposed to do more than this? Well, I figure we might have a couple tinygrad people on by now. Who knows? I said I'd be working on it. We had some before. I don't remember how big to make beam. Is there still other searches? I do not know. I also don't know what this is doing other than taking forever. Number of beams in kernel beam search. Apparently there are docs over like what it searches over. There are settings where you can control like specifically what it does. More options and increased compilation time. Well, I just ran it with 8, so let's see what that does. I have no idea what these are set to. I figured this would be a constant, right? Number of beams in kernel search, yeah. Oh. Okay, Tiny Grad. The hell? That's kind of interesting. Look at that, it found better kernels. That's pretty cool. That's pretty cool. Yeah, we have Viz. Huh. How is it 27 mil? That's after the kernel search. Tiny Jet. No beam on quick start. Equals your first program is slow AF. 2.3x torch. Yep. It does seem like their JIT actually works. Torch's compile does not fucking work. It does seem like their JIT does actually work, so that's nice. There's potential to further speed up Puffer. There's a lot of stuff I like, but there's a lot of stuff that's missing, or not the way that I would want it to be. You can write them in your raw uops yourself. That's not what you would do, dude. You just write your own kernels at that point. The uops are not like easily human writable or readable at all. Like, you want to see what their kernel gen outputs? Here. Let me show you what their kernel gen outputs. Let's just do viz. Yeah. All right, so their kernel gen outputs stuff like this, and then you'll go like look at it, and it's this. So they kind of just manually unroll a bunch of stuff, and if you look here, where is it? Yeah, so they do like they hard code the shapes into everything as well. Probably busy. Yeah, he's at NeurIPS. He like said he sent out this party thing. I'm not going to NeurIPS though. Think you'll still get fusion. But like, why would I write it out? Like at that point, dude, I'm gonna write out a CUDA kernel. Like here, So the point of this, right, is that this generates us decent kernels. Like, I can also just write kernels here. So this is like, I spent 2 days on this kernel, right? Not the RMS norm. That shit's broken. That's actually one of the things that motivated me to look at this. But okay, like here's a Mingru inference kernel. This is actual human readable code, and each of these are just like tiny little element-wise functions. All right, and then like I've got log coefs and values. Here's one. Here's the backward pass. Really, the obnoxious thing about kernels is getting the backward passes to be correct. And then like here's a more complex one. This is the fuse scan operation. This little piece of code took me a couple days. And here's the backward pass for it. It's like pretty small function, very, very fiddly to get this correct. But like the point is this is actually readable and usable output. I can edit this and try to like optimize this. This I can't do shit with. And like on top of that, if at least this were, if this could generate me kernels that would like be size independent, like maybe this takes block size as a parameter or something and it just finds me the optimal default block sizes, I could do that. If this had like unroll in here, you know, instead of hard coding it. But this is like very clearly not meant to be human editable or reusable or whatever. Throw it through Beam. Right, so Beam is going to search over these kernels, right? But like the point is it shouldn't have to manually unroll loops like this to get this level of perf, right? Like it should be able, like this could take a shape arg with an unroll in it and then it would work. Like maybe it would be optimal for this shape, but the kernel would still work for different shapes and would still be pretty good for like, you know, if you double the size, it would probably still be pretty good, right? So like the thing I wanted to do with tinygrad was to use them to generate kernels, right? And then, you know, as I generate more kernels, then maybe it makes sense to have a tinygrad backend and like, you know, a lower level backend. But this makes it very difficult. That said, we're going to keep looking at the beam performance because we did just get a very good result out of it. All right, like actually this one is a good one, right? So this is, I don't want to test this with I don't want to test this with I don't want to test this with the optimizer in the mix. I like to test it like this, right? Okay, so okay, 115 million samples per second out of Torch. Do we compile this just to be sure? Torch.compile. We'll let it attempt to max auto-tune. The hell? With no grad. Oh no, we do need grad on this though. But optimizer zeroes the freaking gradient. Actually, this is an LLM question. Like stupid. In Torch. There is something to backwards through. Flyers grad. That seems bullshit. Detached. That seems bullshit to me. It's supposed to reuse these buffers, isn't it? I doubt that, but we'll try this. Oh, stupid. See, this is like, I hate torch compile so much. It's such a buggy piece of shit. You know what? Does it work with default? Okay, there it goes. Look at that. You compile it with default and it gets way slower. Buggy piece of shit. Fuck torch compile. Yeah. Alright, let's try this one. Tiny jit. Tensor train. Mean dot backward. Oh. Wait, did I do this wrong? I think I did. No tensor core available. Why no tensor core available? Yeah, torch compile just sucks. It's not your imagination, it's just bad. No tensor core. Yeah, that's weird. Alright, let's see this. So the thing is, so far I'm not perfectly happy with TinyGrad's error messages. Error messages. A bit better torch, but still meh. Just put that in there. Like, what the fuck does that mean? No tensor core available. There are tensor cores available. That wasn't even running this piece of code. That was the piece of code that I know is correct. Okay, so there's 106. Torch. Okay, so that's a false alarm, sadly. Those are actually pretty much the exact same speed. Now, the one potential thing that we get out of this The one potential thing we get out of this is we can try like this with 8. How did that search so fast? Why did it just get slower? This might be way too big, right? Oh, I think it's exponential. No, it's not. Okay. 107 mil. So, yeah. That's super inconsistent, man. Like, sometimes it finds the good kernels, sometimes it doesn't. Nah, I do not like that. It finds doesn't did. Oh, not 6, 16. Okay, so we got this one. Search for best performance and save it. Yeah, but like you should not be searching. Like Torch's RMS norm kernel sucks. So you should not be doing that much searching to come up with something about the same speed as Torch. And then sometimes fail and be worse. Okay, we can try Mingru, I suppose. Well, I really just want to try this operation right here. I think that this is a good op to test, right? Because this is the one I have a kernel for. We're watching Ilya? I don't think... Well... I could do that tonight. I kind of want to finish this. What time is it? 7:30? How long's the podcast? Hour 30? Nah. We're gonna have to do that Monday. That's too long. We're doing tiny grad benchmarking tonight, Kevin. Mostly a nothing burger. I'll be the judge of that. Like I said, Ilya's the one person he could get that I'd actually watch it for. Dog. Not Carpathy? Because Carpathy, I go read his code and stuff, man. I follow Carpathy for his technical stuff, not his high-level takes. A lot of commercials in that 1.5 hours. It's called YouTube Premium. Let's see, is it batch T hidden size? I believe it's like this. Yeah, it's Horizon hidden size. Like the podcaster commercials. Oh. Heh. My bad. Well, I'm not going to skip those on the stream either. It's very, very bad form to, like, rewatch something live and not even show their sponsored stuff. What code do you read? This was CleanRL before CleanRL. Older blog posts, and then I also read a little bit of, I forget which one of it was of his, like, lower level implementations. I mean, he's very good at something that I value very much, which is, like, taking the current stupidly overcomplicated thing that people are talking about and making it very simple without losing precision at all. Out equals this. Lost that backwards. I mean, Ilya is, like, from when I was at OpenAI, Ilya and Greg are two of the people I respect the most in tech. Well, in AI in general, I suppose. Admittedly, I didn't really get to see a bunch of Brockman's code, though I did see the type of work he would do with the Dota team. I mean, Brockman would literally just be there coding with the Dota team all day. I kind of got to see, you know, because they were all also at lunch every day. So I kind of got to see the way that they led OpenAI at what was really the golden age of RL, when I think that, well, it's my firm belief that that was where the best RL was happening thus far, like, ever. Dota is by far the best RL project, best RL result. The Rubik's Cube was pretty damn good as well. We were only 2 years out from the original algorithmic breakthroughs, PPO, and there were a few other cool projects at the time. There was a ton of cool stuff going on then. I mean, Dota alone was just so freaking cool to see. Oh yeah, this doesn't have a dot backward, does it? Do I just have to mark this as requires grad? No. Are we alive? Are we back? I think we're back. Damn it, X. Yeah, X stayed down. Let me try to fix X. Gotta love how it does that, man. Just take all of my memory, Torch. Good job. So, the reason that I take OpenAI's Dota result over everything else, it's a 5v5 game, not a 1v1 game, so it's actually multi-agent. AlphaStar's 1v1. Dota is way more heavily strategic than mechanical. I'd say StarCraft is way more mechanical, way more mechanics focused. Dota is like the league for old men, in some sense. The methods used for Dota were far simpler. It really just showed like PPO plus self-play plus a little bit of scale, but nowhere near as much scale as you would expect is enough to solve the game. And it was also trained entirely with self-play, where AlphaStar trained, I believe, up to Diamond, they did imitation learning. So with all those things, like, Dota is a way better project in my mind. It's not even close. Go is very far up there as well, of course, but, like, Go is harder to intuit because the type of difficulty and the type of problem solving in there is far less intuitive and far harder to map onto real tasks than Dota is. Even just knowing a little bit about a MOBA. About MOBAs in general. So that's why. Hopefully this won't take it down. I used way lower batch sizes. Yeah, there we go. Yeah, it's really not even close in my mind. Dota is by far the best. Okay, we forgot Times Horizon. Stratego? Wait, is that actually Stratego? Oh, no, man, not even close. This frickin' game? I didn't even know this existed. Stratego is nowhere even as it, there's no way that's as interesting at all. It's cool that they kept doing this stuff, but this is a really stupid way to quantify complexity as well. Like, Stratego, there's no way this is... I guess I never was good at it. Stratego is nowhere near as complicated as Go, right? Or chess? No. No way. Unless somebody's gonna tell me that Stratego is actually a super freaking complicated game. Huge search space is not a good reason for a problem being hard. Okay, the search space of Dota is way bigger. It's fucking continuous. It's way complicated. I used to play it a lot. It's a lot more like chess in the moves and like the search space in general. No, you're not even looking at as much stuff at a time as you are when you're playing chess. Actually, you know a really easy way to test it? You know what's going to be kind of cool about this? You know how we get to quantify game complexity when Puffer gets a little bit better? We just run Pufferlib on the game, and the games that take more flops are harder. That's it. Yeah, it is about bluffing and stuff, I see. Yeah, that's fair. I have way more respect at the very least for stuff like chess and Go, though, than I do for poker. We're not going to make the same mistake again. We're going to do 512 by 64. This will be better. Some. Let's. Axis. Why you rename this to Axis, man? So we're gonna test. This one is gonna be cool because I have a custom kernel to test test this against. Okay, that's cool, right? Very cool. Yeah, TinyGrad search is the best kernel. And we should honestly, we're going to test it with a few different things. I want this to be like a good evaluation of the thing. And then let's do bump this to 8. That's what we're seeing, crit. So, Jess, chess versus Dota, no way. I take Dota. Chess versus a lot of other things, agree. Search makes it a lot less impressive to me, and all the games have been solved with search. Yeah, this is really annoying that it just found... The fact that it just found a worse kernel with beam 8. Yeah. Okay, so it can like find all sorts of different freaking kernels. It's super inconsistent what speed of kernel it finds. Chess is a very good one because chess is a game that you can actually appreciate a bit very quickly. But also the way that chess bots work make it feel like very unfair to you. Because like of course it can just go check all the moves instantly, right? Like given a good chess engine with fast state sets, you can probably write a ridiculously naive chess bot that already does better than most players. Like literally just do two-step look ahead, you probably already are doing pretty well. For this. Came up with game devs. Oh yeah. Do Well, that doesn't make any bloody sense. I know my scan is way faster than Torchish. Oh, am I using the wrong one? Yeah, I used the wrong one. Hang on. $92 mil. That's quite good. I thought mine was way faster than 2x though. Pretty sure mine was like way faster than 2x. Let's go double check. Yeah. So why is it benchmarking it like this then? This benchmark is way higher. I wonder if it's this. Maybe we're this. Try this maybe. Nope, same speed. We don't need this then. So how is that possible? SPS boosts? Not yet, man. It's not stable at all. I'm trying, okay? Yeah, I don't understand why oh wait, 90 is actually reasonable, isn't it? Yeah, 90 is reasonable. But then why is the PyTorch one so fast? Torch one is supposed to be stupid slow. Am I doing it in double or some bullshit? No, it's float 32. Is it a different batch size, maybe? Test log. BT plus 1H. UK? It's the same thing. So wait, why is it good in one test and bad in the other test? Unless the warm-up is insufficient. No. Same thing. This in float? Very confused. I'm so confused as to how this is. 245 mil. That matches, right? Which that matches. Huh? And then 90. So I guess then the question is not why is it fast here, but why is it fast? Is this cheating somehow? It's not using compile. I doubt this helps. Like, this makes a difference. Well, no, this will actually make a difference. What's this do? I'll stop backward. I mean, why would this... I don't understand how. This one here. See, this doesn't even match. Because this is 230 mil. And then I run this. Here, just to be sure. 192. 512. Yeah. Super weird. Test. Oh, you are not synchronizing here, dude. Yeah, you are not synchronizing. Well, now I'm definitely synchronizing, right? Now I am definitely synchronizing. I don't understand how it's so slow on this profile, and then it's like, oh yeah, I'm just as fast as your custom kernel on the other profile. This one is like, clearly my custom kernel's way better. Right? Damn well hope it is. So confused. Not this, right? I don't know, man. I do not know yet. I'll let you know when I figure it out. So, like, what's happening here is I'm getting some interesting profiling results, but they're inconsistent. So, I want to be really sure before I draw any conclusions. Okay, that's exactly the same as before. This funk thing? If I just do this in here... Oh, I did this in the wrong spot, dummy. It's basically, it's very difficult to tell what's faster than anything else because everything gives inconsistent timings, despite me, I'm pretty sure, not making any of the common idiot errors. I hate PyTorch sometimes, man. So bad. PyTorch. Just a neural net, man. I don't understand how the fuck this runs. How does this shit run, but that doesn't? So dumb. outputs equals fuse scan dot backwards. This is so fucking dumb. You should 100% be able to do this, right? Grads. Oh. Torch drives me nuts sometimes. And then this doesn't have a 0 grad. Dude, I hate this so much. Like, I should be. Welcome, man. Okay, I don't know why the hell that works, but whatever, man. See. Now, why is this ungodly slow? Same freaking speed. Right? Torch is just a piece of shit, is all. Like, it's so annoying sometimes. Ugh. Still better than Jacks. Yes, I read the section about speed. It doesn't tell you much of anything. How the heck is this one slow? No, I'm not going that crazy, right? I'm gonna start. Let's just need more warm-up. Oh wait, how did this get in here? Oh, this is fine. It's still... Okay, this is doing some magic bullshit. Somehow. Warm up. Think. Lost backward. Sync. Steps. Oh, wait, you dummy. See? No, that's fine. So confused. Profile tests are just made to fuck with you, I swear. The thing where it's like always inconsistent no matter how careful you are. Always. You have the literal same copy-pasted code. One is fast, one is slow. What the fuck? Oh, wait, you idiot. Yeah, you idiot. Okay, don't be a fucking idiot. Take two. Still slow? Huh? Now I'm confused. Slow 32 on CUDA. I know what lazy evaluation is. You should still be able to write a profile check, copy paste the code, and get the same result. That seems very odd to me. Okay. I mean, this is just like very stupid, frankly. Okay, good. It's not like an order thing. Used can loss. Oh, it's log vowels. Why is this in float 64? Hold up. Ah. But that should make it even... That doesn't make sense. Well, now we just mismatch even worse, don't we? That's interesting. That explains it. Interesting, though. No, that doesn't make it up. This still bothers the shit out of me, right? Like, okay, so because like if I don't do this, right? If I just do like this, what do we get? Okay, so this matches here, right? Then if I do the backwards, suddenly it doesn't match at all. Why not? Arg.clone .detach wires grad What the fuck? So how's that change anything? Is that consistent? Oh, that's so painful. What's wrong here, man? Like, that's like so fucky that that changes the perf by that much. That doubles perf apparently. Explain to me how that makes any sense. How does that make any sense? Oh yeah, just half the speed, yeah. Oh. Is it just like the warm-up? I'm so confused. It's eager mode. It's not the warm-up. Excuse me? If you mark it requires grad. Oh, that's so obnoxious. It goes to the CPU. Fuck, dude. That's so stupid, though. That's like so stupid. Oh, man, I hate Torch. Why would you ever want that? How do you code without AI? At least, I'm not gonna, like, how do you think without AI, dude? Like, if you're running out of ideas without AI, then AI has taken something very, very important from you. Okay. The worst bug ever. I mean, what is even the excuse for that? Like, what the fuck is the excuse for that ever? I could see it even like what I don't even know what that does. Like, what the fuck? Move gradients back to CPU, I guess? ass. Such a pain in the ass. Alright. We're gonna try this. Okay, way more reasonable, right? Now, let's buffer scan. Now this one makes sense. And I think Tiny Grat actually did well on this one, right? Very well if it's is it cheating? Well, we have to make sure it's not cheating. How do you sync CUDA in Tiny Grad? That's good. Okay. How do we sync? Add sync. Is this made up? Or is this bullshit? Let's see. Lovely, doesn't exist. Good job, Google. Fuck you. Synchronize all pending operations. That looks good. Where is tiled class? Yo, what method is this? compiled. How do I synchronize frickin'... How do you force synchronization? Note that we aren't syncing. GPU time may be slower. Huh? You can time a step with this, but we're not syncing the GPU. So how do you know that the frickin' stream is done? Because that's a good kernel speed, but I don't know if it's real. Can I do .realize on it? Let's get rid of this. This is garbage. Doesn't exist. LMs are stupid. Well, this has .realize on it now, and it's the same speed. So that's actually ridiculous then. If this is faster than my damn kernel. Just get 65. And now it's slower. I mean, they said try beam equals 2. Why would it get slower with larger beam arg? That doesn't make sense, does it? Yeah, and now it's like way slower. Am I misunderstanding what this arg does? I'm using the defaults, dude. Beam equals 4. If this comes from an LLM and is stupid, I swear to fuck, man. Well, it's like, it's slower than beam equals 3. And then you get with beam equals 2. Oh, it's weird. Notably, though, these are all actually faster than the kernel that I wrote, which I spent like 3 days writing. Though it is fixing it is essentially doing the max auto tune. So it's not producing a general kernel. And then when you go to compile the entire thing, it's actually slow again. Which is weird. I mean, this is like enough that it's worth doing more though, for sure. Well, first of all, this is a freaking sequence model, so what are you doing? Oh, this is my, hang on, this is just the forward pass non-sequential, right? Yeah, so you didn't do the full speed of this. So really what we should have and realize Let me actually go check the tiny Discord. Why can I not, why is this all locked? Oh, wait, maybe I can talk in here. Da-da-da. See if we get any replies in there. Maybe you're not supposed to compile this, this entire thing, huh? That might be too large of a segment to compile. I'm gonna give it a minute to see. This, for reference, is what happens with Torch and Jax, is that, like, you get something that looks like this, and then the compile times just become shit. So I'm gonna preemptively... And yeah, that's unacceptable bullshit compile time. Arg's mismatch in Jet. I do. So I... Huh? What I do, man? These fucking errors are just not helpful. Is it the realize on this? No. If I do it without the JIT. How about that? Nine. That's not the same thing, apparently. So slow, man. Args mismatch in JIT. What does that mean? What the fuck does that mean? So confusing. Hmm. What do you even do when you get bullshit like this? It runs normally, it doesn't run with the JIT. What the fuck? in args. If printed. Which args? You don't print the args. They're not even realized because everything's freaking lazy. Like, you can literally hear, if I just delete the tiny jet, if I just do this, right, look. Remove this breakpoint. Okay, so look, now it trains, or it runs. Look at that, it runs just fine. With no jet. Then you turn on the jet. And it breaks. Third iteration, this is apparently when it starts to actually compile. Or use the jitted graph. And there. Same shape, same everything. Wait, it literally printed thing not equal. Did I miss something? Device. Oh, are they on different devices? How does that make any sense? NV. Same device. Oh, it doesn't have a device. But the default is CUDA. Args past stay unchanged. They should be unchanged. Where do I modify anything in place? STVARS D-type device. Yeah, I don't know what that means though. This is first element. This is overwriting. So this is not changing the arg. Right? You'd have to have an in-place op somewhere, I guess. So like where... Still 0. Blame YouTube and restream. Chat delay annoying. Know what the hell this would be. Crazy. Like, every single JIT ever is just a pain in the ass, I swear. I've yet to find a JIT that doesn't make me want to put my fist through the monitor. Be const where shape changes. Oh, I see. This is a giant not equals block. Why is there uops.reshape first and then shrink? Shrink reshape. The same shape. This? Three 128. But this is... It's passing a slice of the tensor to compile. I mean, what? Does it want me to compile this entire fucking loop? Like, then it's just gonna take forever, right? Like, I can do this, right? Too many indices. Didn't JIT anything. So this is gonna need model, logits values. And now it's gonna take for fucking ever. I guess it's not that terrible, but like, ugh. Like, this is too much to JIT. That's really shit that they don't support that. Are you kidding me? It's not dynamic. Literally, none of this is dynamic. That's the crazy shit. I'm like, this is already optimized to not even be remotely difficult to handle. Like, this is me porting little chunks of, like, third generation at least. Realistically, much more than that system. I mean, I guess arguably there is technically a way for me to make this buffer contiguous. There's not a good way for me to do it, though. That is kind of interesting. Massaging is needed. Well, now, congratulations. You've learned why I fucking hate jits. Ah. Make a jit, you know what a massage? Okay, and even if you do it correctly, then you get to wait for a stupid jit to compile. This is going to make a gigantic graph. Right? You see this is going to make a gigantic graph, right? This is calling an entire network inside this blob. I wonder if this is a JIT requirement or a TinyGrad requirement, actually. TinyGrad just straight up not have contiguous sets? Oh. Well, that's fucked. Dude, you guys don't have proper slicing. I mean... Then it'll... Yeah. And we can both see that that's incredibly stupid, right? I mean, honestly, Tinygrad is pretty damn good so far. It's missing enough stuff that there's no way in hell I would just port this to Torch and say, yeah, everybody's got to use. I mean, port from Torch and say everybody's got to use Tinygrad for now. It's like it does a bunch of things that PyTorch doesn't that I'd like, but it's also missing a bunch of shit that I would want as well. Like the low level control is really not very good because it generates you kernels, sure, but it generates you like size specific kernels. As far as I can tell, there's no way to get it to generate you like a generic kernel with a specific block size that you can apply to whatever sized input. What about the RMS norm thing? What was the result of the RMS norm? Try this. 2. Somehow that gives you the magic number. But this is to match Torch Eager mode. The one that like is really ridiculous is the fused kernel, right? I mean, we've got two things that are kind of ridiculous. Okay, and what the fuck is this no kernel available? Fuck is this? Oh, that's bizarre. Better, right? PyTorch XLA scan. But like, I hate the idea of introducing all these complicated ass constructs just to avoid writing anything but Python. Like, I'd rather just not write my networks in Python than deal with this bullshit. Okay, I mean, if you're using the default settings... Yeah, this is the only one that's, like, ridiculous. How the fuck is this faster than my kernel? How fast is this thing without the dot backwards? Oh, interesting. So actually, their backward function is faster than mine. But, my forward is faster than theirs. Huh. How the hell's my backward function slow? I guess I didn't get rid of this one conditional, but, like... Did I forget an exp or something? T... expf, expf. No, I don't have anything weird in here. Do they have some better exp function or something? Actually, kind of weird that my backward is that much slower in the first place, isn't it? How many exps do we have? XF. 2 exps here. Oh, do I have an extra exp? Huh. I don't know. That's weird either way. I guess it could also be overhead from, this whole thing is bound to torch. Size. Two. I mean, I can probably... Let me do one last, like, a couple things, because this is bothering me. take forever. Yeah, that genuinely doesn't seem to help now, does it? This. Be surprised if that's the thing that's slow, but it can't even be that that's slow. That actually does make it a little faster, funny enough. I didn't fuck up anything in the launch. I do have this here. Make sure these checks are not, make sure real quick. Because I'm kind of surprised how the hell that can be faster. Oh, wait, unrolling. Yeah, it's gonna be this, I'm pretty sure, right? Yeah, that's what it's gonna be. Has to be known compile time. This probably is not gonna do anything, right? Yeah, I'm totally fine with that. Like, yay, of course they generate a faster kernel. They get to unroll loops. I'm actually fine with that. Okay, so let's see, do we have any replies? Nope, no replies in that Discord. So conclusion from today. I guess we can say TinyGrad's beam generates us better code than Torch's shit compile. It generates like super specific kernels to do so. So you basically have to have the JIT in there. Man. I'm trying to think what this changes with how I'm doing stuff. It's kind of funny, like, TinyGrad would almost be my ideal thing if it were just written in frickin', I don't know, C or something. Some reasonable low-level language. Because, like, how would I do this with RL? Even if I wanted to use TinyGrad, right? Like, I guess you'd have to have... You literally can't even do it, right? I don't even know if you can JIT. You'd have to, like, JIT just the forward pass. I guess. Hmm. Like, their kernel generation's actually pretty good. The other thing I like is that so the way that they build up that instruction queue, whatever it is, the command buffer, like that cutting out overhead is really good. Though actually, I didn't see that when I opened up the profile. There's still a huge amount of time between launches. like kind of good, but kind of not. I guess it might just be too early as well. Like, once we have the CVEC backend in a good spot, could I see this winning on perf ever? I mean, realistically, I could. But the thing is, it's the reason that I could foresee this thing winning on perf is so stupid. It's just that PyTorch doesn't have like kernel search in their C++ API. Yeah, I know they like to golf their shit more than they should, Liberty. It's still better than Torch though, like the code. I mean, go read Torch's code, it's ass. Go try to literally just go think of an operation in Torch and go try to find the source code. You won't be able to. Like, if you want to have a fun time, go figure out how they do their map moles. Interesting. I mean, unfortunately, the conclusion from this is everything is fucked and there are no good solutions, right? Like, that's literally the conclusion from this. Auto tuner caches. Is this a thing? Yeah, this is not true. Yeah, there's nothing similar to that, sadly. Pip install puffer does not work. What errors are you getting, man? I'm gonna check this and then I'm going to bed. I think. So like I really don't have an answer to this. It's kind of an embarrassment that despite the ludicrous number of billions of dollars poured into ML as a whole, our tensor libraries still suck. Torch is the closest, I think. Yeah, what's wrong? Yo, Hyper, what's I don't see issue here. This installs. You have to paste an error. Yeah, that guy, long stream day. I don't think that there's a good solution to this. Tinygrad has some good stuff. For sure. They're also missing things that you'd want. And the JIT just pisses me off, man. Having to just JIT everything. Tell us what would be the ideal for tensor libraries. Well, I mean, first of all, I'd want an interface that's not fucking Python. I'd prefer C. Lightly C++ would be... Honestly, fuck that. Nah, just C. If it were Zig or something, that would be fine. Just fuck C++. There are a few other languages it could be that would be fine, frankly. Yeah, but then you're using TensorFlow, dude. Isn't that, like, project basically abandoned as well? Because Google's doing JAX now? So you'd want a low-level interface that removes all the Python launch overhead without having to do any form of JIT. You'd want it to do either some sort of... You'd want it to do something like what Tinygrad does, actually. Basically, do what Tinygrad does, but do it in freaking C. So you don't have this slow-ass JIT. I think the thing is you still do have to trace, right? Even if you are in C, I think you still have to trace anyways, because you need to buffer all the kernel executions. Non-invasive and ultra-fast JIT. What I really want is to not need a JIT, dude. Shapes aren't known in advance. We could just make the damn shapes known in advance. Didn't get errors, some stuff didn't work. Not do UV pip. Well, it's gotten a lot of changes. But like, let me see. This work? Yeah, this is Puffer 3 training breakout here. 3.6. Yeah, 3.5 mil steps a second. You know the shapes, you can probably compile. Yeah, the thing is you can guarantee that this shapes will be static for a single run, but you don't want to have to recompile per shape. Yeah, so that guy, here's the thing about Torch Compile with max autotune. It's fucking dog shit. It produces slower code every fucking time when you have small networks. That is a weird result. It should be above 458. Possibly this is a Torch version diff. So that does run. I would imagine Torch version diff on this. Yeah, because that doesn't work as well as it was when I shipped this. I hate Python so much. Well, there's no point in even looking at Torch Compile with max autotune because it produces slower code than eager mode. Slower code than eager mode. Dude. I think TinyGrad's JIT is the best of them so far. Reduce overhead? No, it's not. I've profiled it repeatedly. It still produces slower code. I hate the idea of having to do puffer in C++ and CUDA graphs. Okay, cool, that guy. I'm not doing any of those. It's still ass. I get results out of Torch Compile sometimes on larger networks. It constantly screws up on small nets. It's very inconsistent at the least. Well, this is the thing I'm not sure, right? Because, like, not being in Python eliminates Python overhead, but like TinyGrad actually has eliminated a lot of the Python overhead, at least from the calls into their nets. I'm still trying to think. I hate that it has to be a JIT to do that. But having to be like low level and still traced is also like that's even worse. I guess the benefit would be at least that the JIT would be faster. The JIT would definitely be faster. Coup de graph launch overhead. Coup de graph launch overhead is a decent chunk of it, that guy. We have a shit ton of CPU time, actually. Can I run this? I wonder if this works at the moment. TinyGrad was also able to produce like a 30% faster kernel than my handwritten kernel. Though, like, admittedly, they're basically doing it by generating like a single purpose kernel with everything unrolled, etc., etc. And we're testing this against my generic kernel that works for everything. So my generic kernel is like twice as fast or whatever as PyTorch's kernel. And then theirs is like plus 30% on mine. Yeah, so here you see, we've got a big chunk of CUDA launch kernel, dynamic kernels. Well, I'd like tunable kernels at the least, right? Like maybe you tune the block sizes, but I'd like to not have to have literally code-gen human unreadable kernels. I don't like the idea of taking the, unreadable machine code up another level, right? I don't like the idea of, oh, kernel code shouldn't be readable. That's shit. You're basically taking like the machine code and bringing it up a level of abstraction and saying, oh, people should never have to read that, which I hate that. So yeah, that guy, you can see this right here. You can ignore some of these other things, like a lot of this mem copy overhead is, some of this is going to go down. There's going to be synchronized overhead's going to go down. But this launch overhead, man, there's nothing I can do about this, I think, other than fuse more kernels or do graphs. If this affects LLMs, you are hard trolling. I have so much less margin for error when the networks are this small. Like, my forward passes are 200 microseconds. Launch time is proportional to the kernel size. That, well, not for matmols. Well, for matmols, though, it's, you have more arithmetic intensity, so it's less. I guess your element-wise ops still do. But then the thing is, your element-wise ops should be less of your compute because your matmols are so much bigger and they scale quadratic. Like, so yeah, I still have way less of a margin of error. More fuses won't help. Launch time, wait, more fuses won't help. More fuses absolutely do help. What are you talking about, dude? What do you mean proportional to the kernel size? The input size? I've timed it, and the fusing kernels absolutely does help. Fuses help small model. Yes, that is true. Well, I will write something up on TinyGrad early next week We got the Ilya podcast to look at. We've got the Vec backend to get stable. Vec is going to get us a couple mil steps per second. I think we should get to 5 mil just with good Vec. And then we need to find another 2x overhead in here. Trying out 4.0. I don't know why his comments don't show up. Probably because he tried to post a trace and YouTube filtered it as spam. It's nothing I've done. It's YouTube defaults. I can't change them. Please help him in the Discord if you can. It's 10 though. I gotta get sleep. I'm gonna be lifting weights pretty much all day tomorrow. That's my rest plus exercise day. And I will be back streaming on Monday. So, and I have to think through this as well. So, for everyone who's tuned in, thank you very much. All my stuff's free and open source at puffer.ai. If you're interested, I try to make RL fast and less painful. I also do core research and the like. If you want to help me for free, feed this puffer a star. He likes stars. It actually helps me a ton. Stars go up. And you can join Discord to get involved with dev. You can follow me on X for more RL content, including my educational stuff. Thank you and have a nice weekend. Bye.